Okay, so our next one, we're still working on these videos here, is part 284C3m1b7c8e12c7. This is line 22f1fa19c3m1b7c8e12c7. Radiative Transfer Spectral Radiance 5G Wow Seti. And this is the alien radio signal here. This video is going to cover keyword research that continues from airlift and core designs, the fuel formulas, ideas from previous videos starting at 10A, 11A, 12A, to radiative transfer spectral radiance PDF test results. So if you want to find 10A, you just do all these numbers here up to the 12, and then you add 10A, and it'll bring up the video, okay? Or you can backtrack on the YouTube channel, The Idea Girl Says, and every video is linked to one another, so you can go back. It's about, you got at least 9, 10, 11, 15 videos to go back. Okay, if you're going to work on this airlift for fuel formula stuff. So December 18th, the key radiative transfer from previous videos, grid-based code STEINRAY is the keyword. And it's from line 22, F1fa19c3m1b7c8e12c6. STEINRAY Photon Data Grid Code Radiative Transfer 5G Wow Seti. Quote from Wiki. The keyword radiative transfer is the physical phenomenon of energy transfer in the form of electromagnetic radiation. The propagation of radiation through a medium is affected by absorption, emission, and scattering processes. The equation of radiative transfer describes these interactions mathematically. Equations of radiative transfer have application in a wide variety of subjects, including optics, astrophysics, atmospheric science, and remote sensing. Analytic solutions to the radiative transfer equation, RT, exist for the simple cases, but for more realistic media, with complex multiple scattering effects, numerical methods are required. The present article is largely focused on the condition of radiative equilibrium. The keyword spectral radiance is a quote from the diagram from the blog. Radiative transfer simulation of dust-like aerosols, uncertainties for particle shape and refractive index. And there's the name of our doctors that worked on it. Or, sorry, scientists. I'm half asleep still. And it's New Year's. I'm going to be half asleep tomorrow too. Okay, this is from USA, Texas. Actually from NASA. Hello, NASA. There we go. Okay, so the composition, particle shape, number, concentration, size, distribution, and spatial and temporal distributions of dust aerosols cause significant uncertainties in relevant radiative transfer simulations. The spherical particle approximation has been generally recognized to introduce errors in radiative transfer calculations involving dust aerosols. Although previous studies have attempted to quantify the effect of non-spherical particles, no consensus has been reached as to the significance of the dust aerosol's non-spherical effect on flux calculations. For this study, we utilize a newly developed ultraviolet to far infrared spectral database of the single scattering properties of tri-axial ellipsoidal mineral dust-like aerosols to study the non-spherical effect on radiative forcing. The radiance and flux differences between the spherical and ellipsoidal models are obtained for various refractive indices and particle size distributions. The errors originating from using the spherical model and the uncertainties in the refractive indices are quantified at both the top and bottom of the atmosphere. The dust non-spherical effect on the net flux and heating rate profiles obtained over the entire range of the solar spectrum. The particle shape effect is found to be related to the dust optical depth and the surface albedo, and can be an important uncertainty source in radiative transfer simulation. The particle shape effect is largest over water surfaces and can cause up to 30% difference in dust forcing at the top of the atmosphere. To highlight the effect of particles' non-sphericity on dust radiative forcing is investigated. The particle shape effect is largest over water surfaces. The shape effect could cause a 30% difference in TOA dust forcing. The shape effect is comparable to the refractive index uncertainty effect. So the keywords are non-spherical dust aerosol, radiance and flux, radiative transfer, and broadband. And that's from ScienceDirect.com. Okay. So the keywords from the data, tri-axial, ellipsoidal, continues in the next video. Thanks for watching.